Okay, this is just an opportunity to practice a little bit of what we've talked about functions. This is a good example of what might show up on things like the ACT or other standardized tests. They'll give you, what a function represents, and you have to solve two different solutions or one solution or whatever. So go ahead and pause the video, try it. It's your bell word for today. Okay. So we see that the function c of x equals 17.5 x minus 10 represents the cost in dollars. So the part that we're focused on right now, the function, which is c of x, represents the cost in dollars. So since we know the entire function represents the cost in dollars, that means that c of x is going to be our cost in dollars, right? The cost of x, because x represents tickets. X represents tickets, right? It tells us everything that we need to know. We have x representing tickets, and we know our function represents the cost in dollars. So this means the cost of tickets. X is tickets, cost multiplication of tickets, right? So we know that information. Now we can solve these two. How much does it cost to buy 5 tickets? Well, we know that x already represents tickets, so we just plug 5 in for x. So our function can say the cost of 5 tickets is, and we'll find it, 17.5 times 5 minus 10. And the reason we're subtracting 10 is because there's a $10 coupon, right? The function's already given for us. We don't necessarily have to put that into the equation because it's already there for us, right? So 17.5 times 5, I believe, is 87.5. 87.5 minus 10 is 77.5. So we know the cost of 5 tickets is $77.50. It's as simple as that. All you have to do is read what it says and understand what it means. In a function, in a linear function, there's typically only 2 things you have to know. You have to know what the function stands for, what the cost of x is, or what the f of x is, or whatever. You have to know what that stands for, and then you have to know what x stands for. Once you know those 2 pieces of information, all you gotta do is plug numbers in, and you got it. Does that make sense? Okay. So, how many tickets can you buy with $130? Well, we know that x was tickets. We're trying to figure out how many tickets, so we're solving for x that we can buy for $130. $130 is a cost. We're going to put it in for c of x. And $130 equals 17.5 x, which is $17.50 per ticket, minus our $10 coupon. Now we just solve. All we're doing is we're adding 10. We have 140 equals 17.5x. And now we divide by 17.5. 140 divided by 17.5 is 8. So we know if we have $130 in our pocket and we want to go buy as many tickets as we possibly can, we can buy up to 8 tickets. So that's kind of a better outlook on how to solve functions. We're going to talk about horizontal and vertical lines. This is actually quite simple. A horizontal line, we know, it's like the horizon, right? Goes straight across. It's like you're looking at a flat field in Nebraska. You're watching the sunset on the horizon. It's just a straight line across, right? And vertical lines, which are straight up and down, we kind of talked about this with the vertical line test last chapter. So when we say we need to graph y equals 4. When we are talking about y equals 4, that tells us that our y-intercept is 4. The y-intercept is always where it crosses the y-axis. So, we go up to 4. 1, 2, 3, 4. We make a dot. And in order for our line to cross the y-axis, it needs to be a straight horizontal line. If we did a straight vertical line, it's not crossing the y-axis at a single point. It's crossing the y-axis everywhere, right? we know our y-intercept is 4. There's only one y-intercept in this situation, and it's 4. So in order for only one y-intercept to happen, it needs to be a straight line across, going infinitely to the right, infinitely to the left. It's not curving back to cross y again, right? It's only crossing y once. Same thing goes for x equals -2. It's crossing the x-axis one time at -2. So we have to go to the x-axis, we have to go left 2. Make our dot at -2, and draw a straight vertical line. And again, it has to be a straight vertical line because it's only crossing the x-axis at one point. And that point is defined at -2. If it was curving up and down and cross the x-axis more than once, right? This situation, it's once, one time. That's why it's a straight vertical line. So that's pretty simple, right? Okay. We're going to move on to monitoring progress. Go ahead and pause the video, try to graph these two on your own, and we're going to check it together. Okay, hopefully you've already done that. We look at y equals -2.5. That tells us our y-intercept, where it's crossing the y-axis, is at -2.5. So we go down 1, 2.5, kind of go in between 2 and 3 on the y-axis. Make our point, and it has to be a straight horizontal line because it's just crossing the y-axis one time. And I know it's not very straight, but you guys get the point. We look at number 2. Our x-intercept is 5. That's all we're given. So we go 5 on the x-axis. 1, 2, 3, 4, 5. Make a point. And a straight vertical line. That's all it is. It's a horizontal or a vertical line. It is a horizontal line when you have y equals, because that's a y-intercept. You have a vertical line if it's x equals, because that is our x-intercept. Okay, intercepts. We kind of talked about it, right? The y-intercept is where it crosses the y-axis. At the y-axis, if we make a solid point where our y-intercept is, our x value is 0 every time. If it's on the y-axis, our x is 0 every time. If it's on the x-axis, the same goes. The y is 0 every time. So knowing that, we're going to be able to graph things in standard form much easier. Standard form is very important. We're going to be talking about standard form a lot. When we look at example 2, this equation is in standard form. If we have an x and a y on the same side equaling a solid number, that's standard form. Standard form is written as ax plus by equals c. That's what we got. 3 is our a, 4 is our b, and 12 is our c. Oh, I don't know why I put 3 there. C. 3 is our a, 4 is our b, and 12 is our c. So, knowing that's in standard form, we can graph this equation using the x and y intercepts. We kind of just talked about what the x and y intercepts are. The x-intercept is where it crosses the x-axis, and y has to be 0. So, since y has to be 0 for our x-intercept, we're plugging 0 in for y. And if we plug 0 in for y, 4 times 0 is 0. All of a sudden, our 4y is gone. We're just left with 3x equals 12. So to find our x-intercept, all we have to solve is 3x equals 12. Now, to get x by itself, all we have to do is divide by 3. And x equals 4. So our x-intercept of this equation is 4. Now, the same thing is going to go for our y-intercept. Our y-intercept is where x is 0, so we're plugging 0 in for x. 3 times 0 is 0. That means our x is gone. All we have left is 4y equals 12. So let's solve it. We have 4y equals 12. All we have to do is divide by 4 to get y by itself. We have y equals 3. So we know both of our x and our y intercepts. 4 for our x, 3 for our y. Now all we have to do is graph them. Our x-intercept is 4. That means we're going right 4 on the x-axis. 1, 2, 3, 4. We're making a point at 4. Okay, for our y-intercept of 3, we are going up 3 on the y-axis. 1, 2, 3. Now, if these were two different equations, we would just have a straight line going across and a vertical line going across. But these come from the exact same equation. And since they come from the exact same equation, they are the same line. So since they're the same line, all we have to do is we connect our dots and we show that our line is going on forever and ever and ever in both directions. So that's how we graph an equation in standard form using the x and y intercepts. First, you have to find the x and y intercepts, then you graph. Okay, moving on. Go ahead and try the monitoring progress. What I would recommend doing is making this graph 3, this graph number 4. Go ahead and pause the video, solve both of these, find the intercepts, and graph, and then we can check together. Okay, hopefully you've done that already. To find our x-intercept in number 3, all we have to do is put 0 in for y. So we have 2x equals 4. To solve for x, we divide by 2. Our x-intercept in this situation is 2. Okay, now to find our y-intercept. We plug 0 in for x, we have a negative y equals 4. We can't have a negative y, we can never have a negative y. In order to get rid of that negative, either A, just move the negative to the 4, or B, we're dividing by a negative 1. Y equals a negative 4. So we have our x-intercept at 2 and our y-intercept at a negative 4. Let's go ahead and graph both of them. Our x-intercept's at 2. We go over to 2 on the x-axis, make our dot, and our y-intercept is at negative 4. So that means we have to go down 4 on the y-axis, 1, 2, 3, 4, and make our dot. Now all we have to do is connect our 2 dots and draw our line. Hopefully your line is straighter than mine. You can draw a straight line by doing a lot of things. You can use a ruler, you can use a paper, you can use an index card. I mean, there's a lot of things that you can do to draw a straight line if you want your line to be straight. Okay, same thing goes for 4. We're going to solve 4. Our x-intercept, if we plug 0 in for y, we're left with x equals a negative 9. Nothing to solve, our x-intercept's already done for us. Pretty simple. Okay, now we're going to do our y-intercept. Put 0 in for x, we're left with 3y equals a negative 9. In order to solve for our y-intercept, we need to divide by 3. Y equals a negative 3. So we have our 2 intercepts. We have x equals a negative 9, y equals a negative 3. All we have to do is graph it. So x equals a negative 9. Let's go and graph it. This is our x-axis, right? Negative means we go left. We're going left 9, making our dot. Now our y-intercept is a negative 3. That means we are going down 3 on the y-axis, and we are making our dot at negative 3 on the y-axis. We gotta use green instead of yellow. Okay, and now all we have to do is connect our dots and make our line. All you have to do, find the 2 intercepts, solve for x, solve for y, by putting 0 in for the opposite variable, plot the 2 points, connect them, and you've got your line. Standard form is a lot more simple than you think it is. All you gotta do is find the x and the y intercepts and graph it properly. Okay, now we got a word problem. This one's going to be a little bit more challenging, but we're going to look. You are planning an awards banquet for your school. You need to rent tables to seat 180 people. Tables come in 2 sizes. Small tables sit 6 people. So we know small tables sit 6 people, and large tables sit 10 people. Okay? the equation, which is already written for us, 6x plus 10y equals 180, models the situation where x is the number of small tables and y is the number of large tables. Now, if you do not have the equation, sometimes it might ask you, hey, write this equation. Write this equation knowing that x is what it is and what y is. You should be able to write it based on the information you have. 6 people at a small table. X is the small tables, that's where we get our 6x from. 10 people at a large table. Y is our large tables, that's where we get 10y from. And of course our 180 comes from 180 total people are attending the awards banquet. So that's where we get our 180 from. We have 6x plus 10y equals 180. If you are not given an equation, it tells you how to write it every single time. So now we're going to graph using the intercepts. So to find the x-intercept, we need to put 0 in for y. If we put 0 in for y, we're left with 6x equals 180. We divide by 6. X equals 30. Okay, so when it says interpret the intercepts, I want you to think, when we have 30 small tables, because x's are small tables, how many large tables do we have? 0. We plug 0 in for y. That tells us if no large tables are available, or if the awards banquet just wants small tables, you need 30 of them to sit 180 people. Okay, next situation. Let's find our y-intercepts. Put 0 in for x. Now we have 10y equals 180. Divide by 10. We have y equals 18. Same thing. If the awards banquet is like, I just want large tables, we know we need 18 tables to fit 180 people. Vice versa for 30 small tables, right? That's how we interpret what the intercepts mean. Now you're given your coordinate grid. Sometimes graphing 30 and 18 is kind of difficult, especially when you're only given 10 squares. So for 10 squares, I would recommend probably going up by 3s. Now I'm not going to make you write 3, 6, 9, 12 all the way up because this is a very small graph, right? But I do want you to write something like this. I'm going up by 3s. That way I know that you're going up by 3s. So now I know that each individual grid represents 3 instead of 1. So let's graph our x-intercept first. 30. We know there's 10 total squares. We know we're going up by 3. 30 divided by 3 is 10. That means we are moving 10 spaces to the right. So we're on all the way to the end here for our x-intercept. Okay, and for our y-intercept, we know 18 divided by 3 is 6. That means we are going up 6 squares to represent 18. 1, 2, 3, 4, 5, 6. Those are our x and y intercepts. Now all we have to do is connect our dots and graph it correctly. Put an arrow on both sides showing that we are going infinitely in both directions. And we've done it. We've graphed by using our x and y intercepts, and we've understood what the x and y intercepts mean. Okay, now sometimes you'll be asked to find 4 possible solutions for the context of the problem. So basically what this is asking, what are 4 different ways that someone can order an amount of small and large tables to still fit 180 people? Well, the good news is we already have 2 of them. We already have, if they don't want any large tables, we got 30. So let's go ahead and just write it in coordinate form here. We know we can have 30 small tables and 0 large tables. That's one possible solution. Okay? Another possible solution is we can have 0 small tables, which is our x, and 18 large tables. Those are 2 solutions already. Now we just have to find 2 more. Now you have 2 options here. You can either A, use a calculator, plug numbers in for x and y until you can successfully get to 180 in different situations. But that's going to take a while. Or B, we can convert this standard form equation to slope-intercept form. So that's what we're going to do. and we're going to do it up here so that way you guys can see it. We're taking this equation and we are putting it in slope-intercept form. So let's go ahead and do that real quick. Slope-intercept form is written as y equals mx plus b. We haven't talked about graphing slope-intercept form yet, but that's also another solution you could use. But if we're trying to get y by itself, just like slope-intercept form, we have to subtract 6x first. Then we'd be left with 10y equals negative 6x plus 180. Now our final step to get y by itself is divide by 10. That means we have to divide both these by 10. So our slope-intercept form equation is going to look like this. So 10's eliminate, we have y by itself, right? Negative 6 divided by 10 is negative 0.6x. And 18 divided by 10, or 180 divided by 10 is 18, so plus 18. So this is our slope-intercept equation that we are going to use to find two more possible solutions. Now, if we think about it, we can just either A, use this as an input-output table to find two more solutions, or B, we can just plug numbers into the equation to find two more solutions. So that's going to be kind of up to you. I'm going to try to represent this in an input-output table like we've done in the past. So, in my opinion, the easiest way to get 0.6 to a whole number, because we know we cannot have decimals of a table, right? We're not just going to go up to the company and say, oh, I want 0.6 of a table. They're not going to take a bandsaw and cut the table into a sixth of a table, right? They're going to say, no, that's impossible. You have to order a full table or no tables. So that means we have to plug something in for x to get a whole number for y. The easiest way to get a whole number from 0.6 is probably by moving the decimal place to the right. And moving the decimal place to the right is just multiplying by 10. So if we plug 10 in for x, negative 0.6 times 10 is negative 6, right? So since we have negative 6 plus 18 is going to be 12. All we did was we plugged 10 in for x, and we got 12 out of our equation, just like we've been doing, right? So that's one more solution that we just found. We know that we can have 10 small tables, 12 large tables. Okay, let's do one more. There's tons of different options. I mean, you're not just going to get to one solid answer. If you were to say, I'm going to keep plugging in until I get another solid number, that's totally fine. You can come up with different answers. You don't have to have the answers that I have. As long as you can plug these back into our standard form equation and still get 180 out of it, it's going to be right. But the next one that I would recommend doing, if 10 works, always check to see if 20 works. So we put 20 in for x, because remember, our input is our x, and our output is our y. We put 20 in for x, is that going to work? Well, let's find out. Let's actually solve this equation. So if we have y equals negative 0.6 times 20 plus 18, just like we've been doing, we are plugging 20 in for x. We can put it into our calculator, and we can find that negative 0.6 times 20 is 12. We have a negative 12. What is negative 12 plus 18? Negative 12 plus 18 is going to be 6. So we have two different solutions here, right? Now, I'm sure if you wanted to go in between 10 and 20 and just run this input-output table all the way down, you could find another one where there's two whole numbers. You could. I'm just trying to do what's easiest, in my opinion, right? But we've talked about in the past, you can use your input-output table, and you can go 11, 12, 13, 14, 15, and if you find two whole numbers, use them. That's completely up to you. I will not count you wrong for that. I just think 20 is going to be the next easiest one. So we know we can have 20 small tables and 6 large tables. So that's going to be our fourth solution. So those are our 4 solutions. We can have 30 small tables, 0 large tables, 0 small tables, 18 large tables, 10 small tables and 12 large tables, or even 20 small tables and 6 large tables. Those are the 4 solutions that we can possibly find. Again, we can probably find a few more than that, right? Of course, if you have any questions, please email me or ask me in class. That's probably the toughest part of this entire lesson. Okay. This is a monitoring progress. Go ahead and pause the video. Try it on your own. I'm not going to ask you to find 4 possible solutions in this one. I just want you to graph standard form. Read what it represents. Try to be able to tell me what each intercept represents, like we did earlier, and graph the equation. Okay, so hopefully you were able to solve it. For your x-intercept, you should have 4x equals 180. And dividing by 4, x is going to be 45. That's our x-intercept. Okay. Our y-intercept is going to be the same exact way, except we're putting 0 in for x, right? So we have 6y equals 180. And what are we going to divide by? 6. And y is going to be 30 in this situation. So we know our x and y intercepts, we just have to graph it. Now again, this is a coordinate grid with only 10 squares. I would recommend going up by 5 because they're both divisible by 5. You can do 15 because they're both divisible by 15. That's up to you. But I'm going to say these are up by 5. So I know that each grid represents 5 instead of 1. So we graph our x-intercepts. I'm going to do this in different color. Our x-intercept is 45. That means we have to go right. And if we are going up by 5s, 45 divided by 5 is 9. So we can go right 9 squares. Okay? Now y is 30. That means we're going up, right? It's positive. 30 divided by 5 is 6. That means we're going up 6. Okay, we've got our x and y intercepts. We just connect our graph, draw a straight line, as straight as we can make it. And we're done. So, of course, like I said, if you have any questions, please email me and I can answer, or ask me in class. We've covered how to graph standard form using x and y intercepts. We've covered how to find 4 possible solutions if you only know 2 of them. And we've also covered horizontal and vertical lines based on the x and y intercepts.